We speak about Liferay in the cloud with the OpenShift platform. This talk is for a person who wants know more about the containers or plans to use her in her project. So I'm Achraf Ben Aissi. I'm Liferay TechLead for 10 years, and I'm interested to Liferay DevOps.
My name is Akram Ben Aissi. I'm working for Red Hat for 7 years now as a cloud architect. I'm also an OpenShifter since the inception, means from the beginning of OpenShift. And for people who are asking, we're not married, we're just cousin. And we had the idea for this talk during a barbecue session where we decided to join forces to make this presentation. So what have we tried to do? Basically, our first goal was to try to make Liferay run inside of containers. And the funny thing is that it was like kind of a desert. Not a lot of people tried, but we decided to give it a chance. And we tried also to push a step beyond and to make it run on OpenShift. But we'll see which are the benefits that we could have from making it run on OpenShift. Sorry. We had several issues or several challenges. First was trying to split Liferay into different components and also find a switchable architecture for Liferay to be run on the cloud-based environment. And finally, we also tried to have fun, even if it was taking a few weekends for us. So here are some facts about containers. Who knows nothing about container in the room? Okay, who knows everything? Okay, good. So to start with the containers, you have to know that it's not a new technology. So it's quite trendy these years. But in theory, and so in terms of value, it's a proven technology which has been developed and was running under different names on IBM ZOS, for example, or IBM X with technology called LPAR or WPAR. Containers are different from virtualization. We will go into deeper details just after that. Containers are not portable, which means that if you develop a container image, you can't move it from an OS to another one. You are dependent to the kernel version. So you can run it on Linux or on Windows, but you can have like a container running in the two systems. A funny sentence is that containers do not contain. What does it mean? It means that container only provide a logical isolation. You don't have a physical equivalent isolation. Containers run on an operating system, and they just believe that they are the only process running on it, and they rely on a technology called C groups and namespacing, which are technologies available on the Linux kernel. Sorry. And one important thing is that containers are enterprise ready. I think guys from Google, probably 5 years ago, were telling that everything on Google, every workload that they deploy, runs on containers. So it was not Docker at that time, but other companies, they are doing it, Facebook, Amazon, and so on. But you won't say, okay, this is only big companies. Today, as a Red Hat employee, I'm helping customers to move their workloads into containers, and they are just everyday companies, from insurance company to banks to travel companies to industry and so on. So a small difference between containers and virtualization. If you have a look at how virtualization works, you have to keep in mind that the principles are quite the same for the two technologies. It's to have a big bunch of physical resources and try to split them into smaller parts to maximize the usage and also to provide some kind of isolation. In case of virtualization, it relies on a software called the hypervisor. The hypervisor gives the illusion to an upper operating system that it runs on a dedicated machine. This is called a virtual machine. On the container side, you don't have such an emulation. You just have a single OS which is shared by all the processes running on the machine. And the illusion will be provided by an isolation mechanism. It's C groups in case of the Linux kernel, which will provide the illusion to the process that it is the only one running on the machine. We do also have other mechanisms like namespacing, which provide, for example, the ability for a container to have its own IP address. So every container will have its own IP address. And so you have many standard issues that you usually face when doing a deployment that you can avoid by using containers. Containers made a very easy way to deploy applications. And also for people who are doing it already, you may say that's very easy today to grab an image from Docker Hub, to make it run on your laptop, do some modification on it, push it again, and take this same image, make it run on production. It's quite easy. I mean, we try to avoid, and it's a good mean to avoid, the syndrome of it was working on my laptop. Okay, it was working on your laptop, and it will be working on production and other environments because you take exactly the same binaries and the same code that you will run on the other environments. By having also this technology, you have better resource utilization. This is also something that we have with standard or classical virtualization. You can have sometimes faster start and stop. If you don't have, this is quite a requirement. And also it provides a good tooling to do DevOps and CI/CD, which means continuous integration and continuous delivery for your applications. Sorry, whoa, too fast. What happened? Sorry. I jumped something like 4 slides. Okay, so what happened then? Because it was very easy to deploy, to have your container run and then try to make it live, people started to use a lot of containers. And natively, containers, they don't have something to manage, for example, the life cycle. You don't control how this, you don't control what happened when they stop, because they just run, and when they stop, they stay that way. You don't have something to restart it. And also you have different issues when you want containers to communicate together or to integrate in the information system. So we needed something much more elegant than simple containers. We need something like this kind of tools, which is container orchestrators. The most famous now that we are using also on OpenShift is called Kubernetes. Kubernetes will provide many, let's say, helpers. First, it will give the ability to package your containers when they are running in a wrapper called the pod. Okay, so the pod will give you the ability to scale your application. A pod is something like a scalability unit. You will put containers inside of a pod. The pod will have a single IP address, and all the containers inside the pod will share the same IP address. This is very useful if you have some processes who wants to communicate together and they are in the same pod. But if containers or if pods wants to communicate together, you wouldn't like to hard code the IP address of each pod. First, because this IP address could change. I mean, the pod could crash. The orchestrator will relocate it in another machine. It will start with another IP address. So the orchestrator, Kubernetes for this case, provide a service layer. And this service layer will just provide a persistent IP address across the whole lifetime of the pod, and also a logical name. And you have the ability to reference this name from other pods to communicate to a group of pods serving the same service. Okay? And this is only for internal communication, I mean the service, how it is used. If you want to expose your applications outside of OpenShift, outside of your cluster, we do have a mechanism inside of OpenShift, and it has also other names in Kubernetes called the route. The route will give you the ability just to expose your service on a reverse proxy, which is built inside of OpenShift, and it will give you the ability to make traffic come into your cluster, into your application. And for internal communication, you still rely on internal services. So what happened then? We built, OpenShift provide other services also to manage different issues or different problems that you usually have when you have containers running in production. We added on top of this a routing layer. We also add a persistence storage layer. So because containers they can start and they can fail very easily, they don't keep data themselves. This is the platform which is responsible for bringing and attaching storage in demand. So what about Liferay in containers? if you want to run your application inside containers, there are some very useful patterns that you can apply. First of all, and this is something very, let's say, common in software engineering, it's about separation of concerns. Okay, this separation of concerns, you can deploy it, you can apply it at different level. The level we decided to apply to make Liferay run on OpenShift or make run on containers first, it's trying to separate different components into smaller set of units. Also, you have a confinement that you have to ensure and to give to your process, so he could leave and he could start and he could perform correctly in your container and in your cloud environment. Also, you should have to consider that your application container is disposable, so you have to handle the cases where it crashes and it restarts. You have to consider all your containers the same way. This is why it is important the way that you build your image. And there are other, let's take these first three ones, and there are some other patterns that we can go into detail after the talk. But basically, this is the first three things that we focused on.
To be compliant with these patterns, we have to take a look about the Liferay architecture. As you can see in the bottom, we have the file system and the database communicate with the persistence layer. In parallel, we have the search engine communicate with the indexation layer. Both are communicate with the microservice layer, and the microservice layer is communicate with the portlet and the API layer through the authorization layer. And all of these layers are in the same JVM. And the pet point of this is they are communicate with the message bus, and the remote message bus is not available. So next we will see the modular architecture, and we can see we have 5 big categories of modules. We have the foundation and the front end. We have the workflow, forms and workflow, the collaboration, and the web experience layer. So we have very much modules, and they are. We have big pinpoints in this case because we have many dependencies. It's very hard to disable one functionality of Liferay. So the second pinpoint is, as Brian said this morning, we have an average startup time too long, and it's bad to the scalability. Next, we have to set the focus of why we want to go, why we want to containerize Liferay. And the first part is the container will be a part of Liferay and will be start faster. And the second point is we have to avoid the side effects and the rollback is possible if we have side effect with the containers. And the third point is we can run containers to make a background task and destroy it after, because container is ephemeral. What we do, the first thing is the simplest. In the portal-X, we have separate the database and the search engine. Next, we have disabled in the blacklist configuration some stuff, and the best thing, we have the very big server with with a hardware solution. So 64 giga of RAM.
So yeah, just like Achraf said, we tried to reduce at the maximum, or let's say at the minimum, the startup time for Liferay. And we went from 180 to something like 30 seconds, even without using the 7.1 GA2, which starting this morning, just by removing some stuff. But the biggest benefits that we had, it was by changing with a much performant hardware. So why did we try to tackle these issues? Because we wanted to benefit some feature that we had on OpenShift. These features, they are linked to feature already present in OpenShift, and to have them available, we proposed a specific architecture to benefit, for example, scalability. Scalability is one of the features that we have in OpenShift. Your containers, because they are simple units, stateless-like units, you can scale them and replicate them to absorb more workloads, to absorb more user loads. So we decided to have an architecture which separates from one side Liferay instances who are dedicated to admin to input contents, and on the other side we have other like front-end based Liferay instances which give the ability to scale them in a different manner from the instances dedicated to admins. Also, we relied on two different services that we deployed also in OpenShift. The first one is the database. We used Postgres, and we had a cluster of three cluster containers, Postgres containers, deployed as a stateful set in OpenShift. And we also have the search engine based on Elasticsearch, also deployed in container. And as I said previously, they are all communicating together using services, internal services. Also, we do have different routes for users and for admins. So for a specific set of admins, they are able to access the admin portlet and they can input data and content inside of the container or deploy containers. Where on the other side we disabled the admin tab to make it not possible to deploy content, but only to view it. But it's just a choice for our case. Once we have this architecture, we deployed it into an OpenShift template, which makes possible to deploy this complete architecture just in a few seconds. So even someone who doesn't know Liferay, who doesn't know anything about the Liferay components, he can deploy it. Of course, if he knows, it's better, because he could make it work and he could improve it. But even someone who doesn't know how it works in too details, he can just take the template, have this architecture running, and propose Liferay in a few minutes to customers or developers. Another thing that we benefit from the OpenShift architecture is a auto-healing for failed containers. So in OpenShift, your containers are deployed in nodes. So the nodes are managed by OpenShift, and your containers can live with other containers from whatever project and so on. We just have an isolation between these projects. And if a node fails, you just have the guarantee that the container running on your node will be rescheduled somewhere else, okay? Which means that you have a self-healing of your Liferay cluster. So if you are losing one member of your two admin nodes or one member of your users nodes, they just will be rescheduled and restarted. So this is why we are focusing on having a short startup time, because to make this self-healing and this scalability feature efficient, we need to have a short startup time. Otherwise, it won't be transparent for users. They will see that something is not working for a while. So the shorter time we have for startup, and the better the user experience is. We also pushed to another level, separation of concerns. We built a Docker image for Liferay, which is very minimal, to run only asynchronous jobs, like batches and so on. And sometimes it's even not a Liferay image. We just have an image, for example, to import users inside of Liferay, which uses the JSON API from Liferay. And we are just able to import in background tasks users or documents using this kind of containers. So by doing it that way, we have the ability to discharge the Liferay instances which are used by admins or users, and to run some efficient or highly consuming I/O or CPU tasks on other pods and make them stop just when we don't need them anymore. Sorry. Yeah, finally, we made the deployment easy by just deploying an OpenShift template. So when we have done all this architecture, we just export it as a template. It's a single command in OpenShift, and by just applying this template somewhere, we can rebuild the whole architecture. Yeah. Okay. So here are a small set of pitfalls to avoid. First, if you want your approach, if you want to reproduce the same thing, we'll be publishing the template on GitHub in the next few days. If you want to reproduce something similar in your cloud architecture based on Kubernetes on OpenShift, something that you have to pay attention is your liveness and readiness probes. So these are controls that you provide to the cloud orchestrator to give states about your Liferay instances, how they are running, how healthy they are. So these are they have to be very they have to be very relevant in terms of usage. For example, if you just check that the port 8080 is available, it's not enough as a liveness probe because you have many things starting on behind, which will really determine if your instance is ready, if your container is ready to serve traffic. Also, this the second thing is that because you are running on a cloud environment, you don't have influence on startup order of your containers. For example, you just push the template and the database could start after the Liferay. So you know all that this will cause issues. So you have to take this into account for your probes. And in case of the database is not ready, you just have to even restart your container or do something. So this is something that also we have to figure out. Externalizing configuration, this is something very common in software engineering. You have the same principles and same mechanisms available in OpenShift and Kubernetes. You can use config maps, which is a specific volume. And for our instances that we use, for example, for admin and users, we do have different config maps to have different configuration, different modules enabled or disabled in Liferay. You also have some specific Java options that you can use when you're running your Java applications inside of containers. For example, containers are confined in terms of resources, CPU and RAM, and if they try to use more memory than expected, they will just be killed by a signal called the OOM killer. So if you want to avoid this kind of thing, there is a specific option in the JVM which will size correctly your XMS or XMX based on memory available in the C group you are running on. A thing also that we enabled in the template is Tomcat session replication. And if you want to run this in the cloud, you have to, for our specific case, we use the JGroups implementation, which uses multicast. And so usually in Kubernetes and other cloud orchestrator, you don't have multicast enabled by default. So in our case, we used OpenShift with a specific plugin to enable it. I think that's all. We'll try to move to a short demo. Maybe in the meantime, if you have also questions, I can take them because we are just in time, I think. We have 7 minutes left.
In that case, is that template available somewhere?
Yeah, just I was saying before that...
the mic? No, the mic. Ah, is that template available somewhere for us?
Okay, so I was telling just before that we will publish the template very soon. We were working on a private GitLab repo for the tests, and yeah, we can publish the template very soon on GitHub actually. So just a small demo that I will show you. What have we done? So there are 2 steps in OpenShift. You have the phase where you build images. So we started to build our own images on OpenShift just by creating a specific build. So this is something that I run quite a times, 15 times here. We are using code source here. And every time that we are making a modification in the Docker image, the image is rebuilt. And we have the our deployment rerun. So based on this image, we created a full environment called Liferay Tomcat app. Just if I can find it. I don't see it, but anyway, it was okay. So it's here. And for demo purposes, I just scaled down the number of replicates that we had for Elasticsearch and for the database. So instead of using 3, we're just using 1 here because my server was quite stressed for the demo, and so am I. So
You're doing great.
okay, thank you. So yeah, I reduced the number of replicates, so it was able to run multiple instances for the cluster. So Elasticsearch here has a service. Liferay here has also one replicate, but I can scale to 2, for example. So in this time, instead of having one, yeah, it's very start, but yeah, I think the probe is not very good at that time, so it didn't start right. So this is, for example, the first container running here. We have the logs here. It has some issues, of course. And this, for example, one is linked to the liveness probe. This is something that I noticed. If you want to access the slash URL on Liferay before it is ready, there is a crash here, and apparently there is a Jira open somewhere or an issue. So this could be fixed. Okay, and then we have here the clustering stuff, which is working. I just started right now the other instance, so the other member of the cluster will find its peer and start to replicate sessions in between. So what happened if I try to access the application? We have, as I said, a specific route here to access the application, and same here for the admin side. So if I try to access the application, it's working. It's here somewhere in OpenShift, and I could do just simply the same thing in another project. So I just created a small script to create a project. Let's call it, for example, Liferay DEVCON. So I did this with a script because I have some permission to add to allow other projects to pull my images and to prepare the multicast stuff to work. So let's go back to it. And it's here, it's Liferay DEVCON. It's created by admin a few seconds ago. Okay, so I have here my project. It's completely empty, and I have the ability just to add from the service catalog the template that we have exported before. Oh, finally you have 2. Okay, this morning I was struggling because it was not appearing in all projects, this one. So this one is the one that I like. I was adding it manually. But now here I just have a Liferay template. For now, I don't have any configuration parameter because everything is just generated. And just by clicking next, it will be provisioning all the required things that I would like. And here it's provisioning Elasticsearch, for example. One pod is starting. Here it will provision, it was the old template that I used. It's starting 3, so that's not, it will be quite long. Hope that it will work. And we have here PostgreSQL database. Hopefully it started very fast, and so it will be available for the Liferay instances to start. Okay. So I'm not sure that all my Liferay instances have started correctly. I will just try to grab one, for example. It's taking a few time, and the 3 altogether, they will probably, put the server quite busy. So in the meantime, we will pray and wait, hopefully that it is working, and I will get some questions so we can check if it is working in a few seconds. So this was the other instance.
Thank you.
Tell me, please, how we can use your schema with deploy some application to the Liferay.
Okay, so we didn't manage this this part of the development workload. Usually, when you are doing development in OpenShift, you can have specific Jenkins pipeline, we do have an integration with Jenkins. So you can have a Jenkins pipeline and have access to all your project and OpenShift objects inside of your deployment. So you can just imagine that you can have hot deployments for some components, or you can build some portlets and so on, and then deploy them in the running OpenShift. But for our scope, we didn't went into this topic.
Okay, thank you.
About the Postgres, you mentioned you had 3 running in a reference architecture, probably not this one because the server is overloaded.
Yeah.
Is that 1 write server and 2 read replicas, or is it some other clustering?
This is something also I discovered when trying this project. The thing is that in PostgreSQL, you must have to. I mean, you can't do anything than having one master and replicas, and you don't have the ability to have automatic failover with Postgres. So you will have the ability to have read-write access on the master, and this is something that could be missing, for example, in the JDBC driver for Postgres, something like that. You can have read-only access on the 2 other replicas. In OpenShift, it will be using a different type of service. So you have the master service on top of Postgre, and the other one would be the replicates service. So the good thing is if you have some read-only instances or read-only processes that will work on Liferay. For example, if it is the case for users who are only getting content and not putting content in them, but I think there should be anyway some stuff written in the database, for example, for traffic analysis and so on. But you can imagine that you can have such a service configured for user portal, and the other one would be used by the master service would be used by the admin portal. There is apparently a solution which exists to handle this. It's made by a company, and I think it's open source also. It's based in Sweden. It's called Several Nines,
Yeah.
and they are making a component called Cluster Monitor or something like that. And they are doing specific components to do load balancing based on request type and so on to PostgreSQL servers. So this could be done that way. I think this is something I'm going to explore because it's a very interesting topic.
It is.
Yeah, and if you really want to make highly available Liferay or even something else based on Postgres database, it's a good way to do so.
Okay, thank you.
We'll try to access the Liferay instance. Hopefully it will be starting. Okay, I think we have the welcome title here updated. So again, the first startup is quite difficult. During the session this morning, I was happy that the starting type was okay, here it's working. Yeah. We have it. Okay. Yeah, this morning I was happy because all the issues that Brian was talking about was something that we faced already, and we were happy that some work would be done about it. And yeah. Another question?
Yes, you said you removed some useless stuff in order to improve startup. Could you explain which those modules are?
You have a file configuration in OSI modules to put the modules you want to disable in the startup.
Yeah, that's sure, but which modules do you think are useless?
You want the list?
Yes.
Okay.
We need to publish this also. Don't shoot.
Okay, I can. Je sais pas.
You should have 30 seconds to show it.
Yeah. Okay.
Probably.
Take a picture if you need.
And you can see some thread in Liferay forum with a part of this list.
Okay.
Do you remember the file, Achraf? This one, I think. So it's we don't know it by heart, but okay. Can you read it? Okay. Okay.
Perhaps it's easier to make a whitelist instead, right?
Yeah, probably. So indeed, it's a very long.
They removed everything.
It's a very long list indeed. Yeah.
Can you still log in?
Probably we need to try GA2, right? And
Yeah.
to see if it's still.
I tried during the break time, but it was short to try to run the full demo with only GA2. But we are. Hopefully, I will do it. I will do this probably when back in home.
Thanks a lot.